All right, so this video is going to cover example 4, which has us converting rectangular coordinates to polar coordinates, where we're told the radius is positive and our theta value is always between 0 and 360 degrees. A very key point here is that we are always going to be rounding to 3 decimal points. The trick to this is utilizing the equations r equals the square root of x squared plus y squared, and theta equals tangent inverse of y over x. And that x and y are coming from the corresponding rectangular coordinates. So we're going to be given the x and y. We need to use those equations to come up with the corresponding polar coordinate. So example A, and remember, this is a a rectangular coordinate. So here we know that x equals 5, and we know that y equals 8. And we want to take this information and get to the point where we have r, comma, theta. So that first step that we're going to take is we're going to go ahead and calculate what r is. We are told that r is equal to the square root of x squared, which is 5, plus y squared, which is 8. So we're looking at the square root of 25 plus 64, which is equal to the square root of 89. And I say that that is approximately 9.434. And I'm just plugging that into my calculator and rounding to 3 decimal places like I was told. So that gives us the first component of our polar coordinate, our r value. The next piece of this is to determine our theta value. We were told that theta can be calculated by using this equation, tangent inverse of x over y. A couple key points here is that you're going to use if you use a calculator, you need to make sure that it is in degree mode. And I know that I have to use degree mode because I was told up here that theta is between 0 and 360 degrees, right? I know that those are degree measurements, so anything that I'm giving my calculator, it needs to match up with that. So my calculator needs to be set to degrees. So we will utilize our calculator. You can use your own calculator. You could use an online calculator. If you have trouble with this piece, if you aren't quite sure how to use the tools and technology that you have, please go ahead and reach out to me and we'll make sure that we get you connected with some sort of way to do this. And I just realized that back up in this step, I wrote my ratio upside down. So this should actually be y over x. I apologize about that. Maybe some of you caught that as you were watching this. So we need to go ahead and take tangent inverse of y, which is 8, divided by x, which is 5. And this is, again, all calculator work. So I punch that into my calculator and I round to 3 decimal places as I was told, and I get that this is 57.995 degrees. So I get a final answer here then of my polar coordinate r comma theta is equal to 9.434 comma 57.995 degrees. Not something we'll probably have to graph, but good to know that we can go from rectangular to polar just like we were able to go from polar to rectangular. All right, so in B, we are told that x equals -4 and y equals 1. And our goal is to go ahead and get this to some r comma theta, right, utilizing those equations we were given. So our first equation that we were given tells us that r is equal to the square root of x, which notice is negative. We're going to go ahead and take that negative and square it, plus y, which is 1 squared. Okay, so this will equal the square root of 16 plus 1, which is the square root of 17. And utilizing my calculator, I can say that that is approximately 4.123 when rounded to 3 decimal places. Okay, next we're going to go ahead and calculate theta. Theta comes from that kind of more complicated looking equation, that inverse tangent of y over x. Okay, so inverse tangent of y, which is 1 over x, which is -4, gives us a theta value of -14.036, which makes me pause because I was told that my theta values, remember, they were supposed to be between 0 and 360 degrees. So here, we're not quite done, okay? We actually need to do a little bit more work here. We need to go ahead and take -14.036 and add 180 degrees to get back into that interval from 0 to 360. In doing so, we get the angle measure of 165.964 degrees. So with a little bit of an extra step, we are able to find that for our polar coordinate, our R value is 4.123 and our theta value is 165.964. So R comma theta equals 4.123 comma 165.964 degrees. Okay, you guys have a couple examples to try on your own. It just looks like 5 and 6. Again, notice that you are to be utilizing R is greater than or equal to 0. So that tells us that when we were taking the square roots, we want it to be positive. And then theta is between 0 and 360 degrees.